Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to discuss in our today's video is definite integral as a limit of a sum. In this video, we are going to learn how to write an integral that can be represented as a limit of a sum of infinite series. Please imagine a curve above the x-axis. The function of this graph is a continuous function defined on a closed interval a, b, where all the values of the functions are non-negative. The area between that is bound between the curve, the points x is equal to a and x is equal to b, and the x-axis is the definite integral a to b f of x dx of any such continuous function f. Please look at this following graph. Please have a glance over this. To understand this graph, let's evaluate the area PRSQP between the curve y equal to f of x, x-axis and the coordinates x is equal to a and x is equal to b. Now divide the interval a, b into n equal subintervals. So this can be denoted as x0 to x1, x1 to x2, x2 to x3 and xn minus 1 to xn, the last one, where x0 is equal to a and x1 is equal to a plus h, x2 is equal to a plus 2h, x3 is a plus 3h. It keeps on going like that. A value in between, xr would be equal to a plus rh and xn would be b, which is nothing but a plus nh. All these are suffix 0, 1, 2, 3 and minus 1 and all. So please have a glance over this. Okay, hope you're clear till this. So this is all about the graph. From this one we can find an expression for n. N can be written as subtract a from both these sides and divide the entire equation throughout by h. So n is equal to b minus a over h. Also please notice that as n tends to infinity, h tends to 0. So this is all about, you have to know about this graph. Now the region PRSQP under consideration is the sum of all the n subregions, where each subregion is defined on subinterval xr minus 1 xr, where r is equal to 1, 2, 3 to n. Now look at the region ABDM. ABDM. In this figure, we can make the following observation. Area of the rectangle ABLC is less than area of the region ABDCA. Am I right? And that is also less than area of the rectangle ABDM. So let this be equation number 1. Let this be equation number 1. Also please notice that as h tends to 0 or xr minus xr minus 1 tends to 0. All these the three areas becomes nearly equal to each other. So hence we will have, I'm going to write an equation for Sn and capital Sn. Let me show it for you. I'm going to rewrite the same thing as an summation. So h outside, and this can be written as summation of f of xr, where r is from 0 to n minus 1. Let this be equation number 2. Now I'm going to do the summation for the right side, starting from f of x1 to f of xn. Let this be equation number 3. Small sn and capital Sn denotes the sum of the areas of all lower rectangles, and this is for the upper rectangles raised above the subinterval x r minus 1 to xr, for r is equal to 1, 2, 3 to n respectively. So to bring it into perspective, equation 1 can be rewritten as the sum of the area of all lower rectangles is less than area of the region PRSQP, that is less than sum of the areas of all the upper rectangles. As n tends to infinity, these strips become narrower, the rectangle strips. Furthermore, it is assumed that the limiting values of equation number 2 and 3 are the same in both the cases, and the common limiting value is the required area under the curve. Symbolically, we will have, this is nothing but the area of the region PRSQP and integral f of x dx from a to b. This would be equation number 5. This area is also the limiting value of the area which is in between that of the rectangles below the curve and that of the rectangles above the curve. For convenience, we shall take the rectangles having height equal to that of the curve at the left hand edge of the each subinterval. Hence, equation can be rewritten as, I am going to rewrite this equation. So this can be rewritten as integral over a to b f of x dx. This can be written as limit n tends to infinity h of f of a plus h till f of a plus n minus 1 h. Or the same thing, the integral over a to b f of x dx can be written as b minus a. I'm taking b minus a as a common factor outside and limit n tends to infinity 1 over n. And this would be the same. So let this be equation number 6, where h is equal to b minus a over n. Hope you remember that we initially found. N tends to infinity, this thing, h tends to 0 as n tends to infinity. This equation is the definition of definite integral as the limit of a sum. Hope you're clear with this one? Hope you're clear with the equation, the definition of a definite integral as the limit of a sum. Please notice that the value of the definite integral of a function over any particular interval depends on the function and the interval, but not on the variable of the integration that we choose to represent the independent variable. Hence, the variable of integration is just a dummy variable. Hope you are clear with this one? Okay, now let's look at an example. Here is an example question. Please have a glance over this. We are supposed to find the definite integral as a limit of a sum. So here I'm going to use the equation that we just found. So from equation 6 that we just found, I'm just going to write that. So in this equation, a to b f of x, and please notice that h is equal to b minus a over n. We are just going to use this here. Just compare the definition with the example question. We have a, in the place of a we have 0, and in the place of b we have 2. And the function f of s is replaced by x square plus 1. So what would be the h here? b minus a. So 2 minus 0 over n. So that is going to be the h here. So therefore, this integral can be written as, I'm just going to apply. I'm just going to replace b, a and n according to this. Hope you are clear till this step? Okay, now to limit n tends to infinity 1 over n be the same. Now just replace these values. When x is equal to 0, f of x would become 1. When x is equal to 2 over n, f of x would become 2 square over n square. And 2 square over n square plus 1, right? Same way you have to plug in all the x values in the function f of x square plus 1. So after plugging in all these values, I get. Hope you are clear till this step. So step by step what we are going to do is just simplify each and everything using algebraic manipulations. Just take the squares, or you can also do one thing. You can separate all the ones separately and the squares and combine them. Did you notice that I have separated ones and all the squares separately? So this is one way of simplifying. This would make our job easy. So after this, let me simplify this and write this as an equation. Are you clear with this step? Now let's simplify it further. 2 squares. Now expand all the squares. So I have expanded all the numbers. By simplifying, I'll get, as n tends to infinity, 1 over n tends to 0. Therefore, we will have, I'm taking 2 outside, and if I simplify this, I'll get 1 plus 4 over 3. So if I add the fractions, I'll get 7 over 3 times 2, so 14 over 3. Hope you're clear with this example. The definite integral of any function can be expressed either as a limit of a sum, or if there exists an antiderivative f for the interval a comma b, then the definite integral of the function is the difference of the values at points a and b. A more rigorous treatment would show that integration is a process of adding or summation. By viewing integration from this perspective, it is possible to apply the techniques of integration to finding areas, volumes, centers of gravity, and many other important quantities. We will be discussing one by one in our upcoming videos. The answer, the quantity from this method gives us an estimate of the area under the curve, but it is not exact. The lower and upper limits on the sum corresponds to the first rectangle and last rectangle, where x is equal to a and x is equal to b. It will be sometimes be necessary to go through the process of dividing a region into small sections, performing a calculation on each section and adding the results. That's the reason we are taking summation here. So in order to formulate the integral required. This summation method will prove the fundamental thing. Hope you're clear with this video. In case if you get any query regarding this video, please feel free to let me know. See you in the next